All right, everybody, the Honors Geometry crew. We're on to our next section today, section 10.8, Geometric Probability. This is actually one of the easier sections. I'm going to do, once again, the first 5 problems from your lesson check on page 671 of your textbook. And if you looked at the picture that I put up there, basically what we're looking at here is geometric probability is just the length of, whatever your favorable segment or your favorable area is divided by total area or total length of the segment. So it's actually pretty easy. And when I talk about favorable, that just means what do we want to have happen. All right, so let's all put our transition glasses on, make sure that we turn those bad boys on, and let's get rolling here. So we got number 1 is asking if you choose a point on this line segment, and they called it point T, and if we choose a point on this line segment, what is the probability for number 1, they say, that it lands on segment AB? All right. So you're basically just saying like, oh, hey, I'm going to pick a point anywhere on here with my eyes closed. What's the probability that I choose it somewhere between A and B? All right. The hardest part about this is let's make sure we have the total length correct. The total length of this entire line segment, it is not 10. Students also make the mistake of counting the dashes. So like, 1, 2, 3, 4, 5, 6, 7, 8. Nope, that would be wrong. So let's try to stay out of poop school here. And we count the empty spaces. 1, 2, 3, 4, 5, 6, 7. Or just use your distance equation. You got 10 minus 3 is equal to 7. So the total length of this is 7. What is our favorable length? 6 minus 3, which is 3. So the answer to number 1 is 3/7. Number 2, it says AC. What's the probability we land on AC? Well, once again, total is 7. AC is 9 minus 3, which is 6. So 6/7. All right, number 3, it says what is the length or the probability that you land on BD? All right, so BD, once again, total length is 7. BD, 10 minus 6 is 4. 4/7 is your answer. And then for number 4 is BC. What's the probability we land on BC? Well, once again, total is 7. BC, 9 minus 6 is 3. 3/7. So you can see how that is actually pretty easy. All right, now let's get to number 5. Look at that, I already drew it. I'm already prepared, which is what all of you should be during these weeks that we can't see each other and we can't have the kind of fun that we have been having in class. So let's try to get this down pat. Now, if you like my drawing, I was actually pretty impressed with my drawing, getting that circle touching one point on every side of that hexagon. It's probably just because I'm pretty awesome at everything. So, number 5 says a point K in the regular hexagon is chosen at random. Once again, it's like you close your eyes. Point K is chosen at random somewhere inside of the hexagon. What is the probability that K lies in the region that is not shaded? All right, not really sure why they all of a sudden are switching up. Oh, hey, let's check out what's the area of the not shaded when up to this point everything has been shaded. So basically what they're saying is, what's the probability that this K lands in one of these white spots? All right, well, we got to take the area of this entire thing, all right? We take the area of the entire hexagon. Now, the area of the entire hexagon is 1/2 AP, all right? So, the area of the entire hexagon is 1/2 AP. We need to know what our optimum is. We need to know what our perimeter is. Well, we can figure out perimeter, right? They tell us that one of the side lengths is 10.4. So 10.4 times 6, 62.4. So I know that the perimeter is equal to 62.4. All right? We need to know the apothem. Now the apothem, remember, the apothem goes from the center straight down. All right, remember when we did these problems before? Look at that, I got a different color now. So we need to figure out what this length is, x. Well, we know what the length from here to here is, correct? All right, the length from there to there is just 10.4 divided by 2. All right, so the length from there to there, 5.2. All right, now this is a hexagon. Remember, a hexagon gives us a 30, 60, 90. And if the shorter leg of a 30, 60, 90 is 5.2, then this should equal 5.2 times the square root of 3, which is 9. And now, all of you are probably saying, well, what was this information for? This 18. Well, the distance from here all the way across is 18. So you're saying, why didn't we just divide 18 by 2 to get our 9? Well, we could have done that. All right, we could have done that to get 9 for our apothem. But I wanted to show you how awesome I was. And you can also just see 5.2 times the square root of 3, if you do that on your calculator, equals 9. All right, it's actually like 9.00000 something something. All right, we actually have enough information here. The area of the hexagon, 1/2 times 9 times our perimeter of 62.4. So 1/2 times 9, that's just 4.5. So if we do 4.5 times 62.4, I have 280.8. Now, we need to subtract out the area of the circle. All right, area of circle, which is pi r squared. All right, well, we know what r squared is. All right, 9 squared is 81. All right, so basically what we're doing here is we're taking 280.8, we're subtracting out the 81 pi. So we should probably calculate that out. All right, we should calculate what 81 pi is. It's 254.46. All right, so we have 280.8 minus 254. We'll just call it 5. All right, now 280.8 minus, I'm just going to do the answer here. So you get 26.3. All that told us is what the area is of the white regions. But according to geometric probability and what we were doing up here, what goes in the denominator? What always has to go in the denominator? The total, all right? Its favorable outcome, which is this. This is our favorable, all right? Over total. We already found out what the total is. The total is the entire hexagon, all right? So it's 26.3 divided by 280.8. Now, we got to make sure, we always have to be using the same units. Here we got centimeters. I forgot to write centimeters there. So we're good to go. But 26.3, if you just do this on your trusty calculator, unless it's a Casio, all right, divided by 280.8, I got 0.09, all right? Now, when we convert that to a percent, you move the decimal twice. So the answer, 9%. All right, and you'll have some fun with this. I know you guys will have a ton of fun with this. Like in the later questions. All right, the later questions in the book, I always get questions about these. All right, these over here, these 4. And if you notice, I'm only having you go up through 20, even though I did give you an example of how to do this on the worksheet, all right, that I took a picture of and I posted it. But I'm only having you go up through 20. These ones are great, all right? So here, you got to find the total area, which is the circle, and you want it to, look at now, lies in the shaded region. So, hey, thanks for switching that up on us. So we want our dart or our point to fall in that shaded region, all right? So our total is the whole circle. And where do we want it to land? Well, like yesterday, you got to find the area of that sector, all right? Here, the area of the entire thing, all right, is this whole big square. You got to subtract out the white, all right? Over here, area of this whole circle, subtract out the white circle. And over here, all right, we just have 4 circles inside of a square, which is 12 by 12. All right, these 4 problems should be pretty easy for you to do. But make sure you study, make sure you do the homework that I assigned. You'll have a short, just like we've been doing, little quiz on Monday. I promise you it won't be difficult. All right, hopefully everybody's staying safe. You can now turn your transitions off. Everybody in that back row, like Mikey Gall or somebody wake up Mikey Gall so he can get to his 2nd hour class. All right, but hopefully everybody's having fun. All right, keep your chin up, keep your heads up, and hopefully I get to see you soon. See you later.